Hello everyone, this is Prashanth, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the last previous session, we have discussed IoT protocols. IoT protocols. In that, we have 4 layers: data link layer, network layer, session layer, like that. So, in the data link layer, we have different protocols like 802.3, that is Ethernet, 802.11, that is Wi-Fi. So up to the last session, we have discussed these two topics: IEEE 802.3 Ethernet, 802.11 Wi-Fi. So up to the last one, what are the advantages? What are the applications? What are the applications we have discussed about these two things. So now I am going to explain the third protocol of a network layer, that is 802.16, that is WiMAX. So before entering into that, first we have to know what is the acronym for WiMAX and what are the advantages, what is the main concept or what is the main goal of 802.16 WiMAX it is. So we have to know these basic things for WiMAX. First, WiMAX is, what is that? So WiMAX is the acronym for, it stands for Worldwide Interoperability for Microwave Access. So worldwide. So worldwide we know, so interoperability communication. So it is one of the future of IoT device, as we already discussed in the first session. Interoperability is one of the main future of IoT device. So what is that meaning? So interoperability communication means we have different networks. For different networks, different devices we can operate. So for different networks, we can operate different devices also. For example, here in this room, we have a Panasonic AC. Panasonic AC available in this room. So this Panasonic AC will operate with my mobile. In my mobile, there is a MI application is available. So with that MI application, I can operate with the Panasonic AC. So here the network is same, but the companies are, the network different devices are available. So this is the one of the future of interoperability. The meaning of interoperability is nothing but this one. So different network, either different devices, we can operate with the same link. So this is about interoperability. So worldwide interoperability for microwave signal access. So this is the stands for initial acronym for WiMAX. Next, based on wireless MAN technology. So wireless metropolitan area network. So generally we have a LAN, PAN, WMAN, MAN, we have different technologies. So the WiMAX belongs to wireless MAN technology, metropolitan area network. It is belongs to. Next one, the wireless technology optimized for delivery of IP-centric services over a wide area of network. Next is scalable wireless platform for constructing alternative and complementary broadband networks only. The last one, a certification that denotes interoperability of equipment built in IEEE 802.16. The IEEE 802.16 working group developed standards that address two types of usage models here. So in the WiMAX 802.16, basically we have two standards to operate smoothly. The two types are, first one is fixed usage model. Technically, it is IEEE 802.16, that is developed in 2004 only. The second standard is a portable usage model, that is IEEE 802.16e. So these are the two defined standards for WiMAX. A fixed usage, it is fixed for IEEE 802.6. Either in portable, it may dynamically, it's changing from depending on the usage. So it is IEEE 802.16e. So these are the two basic standards for WiMAX. Next, what is WiMAX? So WiMAX is one of the hottest broadband wireless technology around today. So our current some real-time applications developed through WiMAX only. Next, WiMAX systems are expected to deliver broadband access services to residential enterprise customers in a economical way. So, initially, it is expected to deliver broadband access services to residential enterprise customers in a economical way. Next, WiMAX is a standardized wireless version of Ethernet intended primarily as an alternative to Wi technology to provide broadband access to customer premises. First, it will deliver broadband access service to residential, then broadband access to the customer premises also. WiMAX would operate similar to Wi-Fi 802.16 related to 802.11, but at higher speed over greater distances and for a greater number of users. So this is the one of the advantage over 802.11 Wi-Fi. So this is these are the few points regarding WiMAX. Next, coming to 802.16a, we have defined two operating modes. One is portable, second one is fixed. What is 802.16a? It is such a term that people tend to use it for 802.16 standard technology themselves, and also strictly it applies to the only system. 802.16a standard for 2 to 11 gigahertz is a wireless metropolitan area network technology that will provide broadband wireless connectivity to fixed, portable and nomadic device. So the basic operating frequency ranges from 2 to 11 gigahertz for a wireless metropolitan area network. So we already know, so it belongs to wireless metropolitan area network within the range of 2 to 11 gigahertz. So it can be used connected to 802.11 hotspot to the internet, that is belongs to Wi-Fi, provide campus connectivity and provide a wireless alternative to cable and DSL for the last mobile broadband access. So these are the some limitations of WiMAX in terms of 3 sentences. The first, it is belongs to wireless metropolitan area network within the range frequency range of 2 to 11 gigahertz. Next, move on to the speed and range of WiMAX here. So the WiMAX expected to initially up to 40 Mbps capacity for wireless channel for both fixed and portable applications. So here we already know we have two standards, fixed and portable. For both fixed and portable applications, it can provide 40 Mbps capacity, megabits per capacity, megabits per second capacity. Next, WiMAX developed to provide wireless broadband to buildings either in competition existing wide networks or alone in currently unserved rural or thinly populated areas also. Next, WiMAX could potentially be deployed in a variety spectrum bands, that is 2.3, 2.3 gigahertz, 2.5 gigahertz, 3.5 gigahertz and 5.8 gigahertz. So these are the some variety of spectrum bands it can allow by WiMAX. Next, it can also be used to connect to wireless local area hotspot to the network. WiMAX is also intended to provide broadband connectivity to mobile devices. So these are the speed and range capacity of WiMAX. Basically, it provides 40 Mbps megabits per second capacity within the spectrum bands of 2.4, 2.3 gigahertz, 2.5 gigahertz, 3.5 gigahertz and 5.8 gigahertz. Next, move on to the IEEE standards. Basically, basic IEEE standards for WiMAX is basically Wi-Fi is based on IEEE 802.11 standard. Then WiMAX is belongs to based on IEEE 80.16. Next, it is the range. Wi-Fi is typically provide local area access for a few hundred feet with the speed of 54 Mbps. A single WiMAX antenna is expected to have range of 40 miles within the speed of 70 Mbps or more. This is the range capability of WiMAX. Next, what is scalability? Wi-Fi is intended for LAN applications. Users can scale from one of tens with the Subscriber of each CPE device, fixed channel size is 20 megahertz. The maximum fixed channel size is 20 megahertz. Generally designed to efficiently support from 1 to 100 of consumer premises equipments. It is behind the CPE. So finally the fixed channel size from 1 megahertz to 20 megahertz it having. So the flexible channel size from 1 megahertz to 20 megahertz for WiMAX. So these are the some IEEE standards for WiMAX. Basically Wi-Fi is based on 802.11, 802.11. Then WiMAX is based on IEEE 802.16. 16A, 16.16E. So these are the some IEEE various standards for WiMAX that is coming on next slide. So these are the bitrate and quality of service. So the bitrate of WiMAX works at 2.4 Bps, can peak up to 54 Mbps in 20 MHz channel. WiMAX works at 5 Bps per Hertz, can peak up to 100 Mbps in a 20 MHz channel. Next, coming to quality of service, Wi-Fi does not guarantee any quality of service, but WiMAX will provide your several level of quality of service that we'll discuss in next slide. So next, move on to the silent features of WiMAX. It is very important to know. So we have several silent features of WiMAX, that is in terms of some titles. So we have the first feature of WiMAX is we have two norms of wireless systems. Two forms of wireless systems we have, line of sight and non-line of sight communication. So what is line of sight communication? So here I mentioned line of sight. Basically the full form of that is line of sight communication. It is one of the advanced wireless communication technology. So line of sight is nothing but shortly LOS. So for example, this is a transmitter, this is a receiver. From the transmitter we are transmitting some signals. So for the transmitted signals, the receiver also in phase with the transmitted signal. Then only the information received by receiver is very perfectly. Compulsory the receiver is in phase with the transmitter. The best example for LOS communication is Dish TV. Dish TV or Tata Sky or Reliance Digital, like that. So these are all based on line of sight communication only. So the best real time example for line of sight communication is Dish TV, Reliance Digital, Tata Sky or Sun Direct, like that. So here we have two forms of wireless service, that is non-line of sight and line of sight. So in non-line of sight, it is a service Wi-Fi sort of service. Here a small antenna on your computer connect to the WiMAX tower. In this mode, WiMAX uses a low frequency range up to 2 GHz to 11 GHz, similar to Wi-Fi. So in the non-line of sight feature of WiMAX is we have only transmit low frequency range, that is 2 GHz to 11 GHz, that is similar to Wi-Fi. Next, coming to line of sight communication, it serves a fixed dish antenna point straight at the WiMAX tower from a rooftop or pole. The line of sight connection is stronger and more stable, so it's able to send a lot of data with fewer errors. And sometimes there is no errors. Line of sight transmission on use high frequencies with ranges reaching possible 64 GHz. So this is the main advantage of line of sight communication. This is one of the silent feature of WiMAX. So this is the first silent feature of WiMAX. Next, move on to the remaining three of features of WiMAX is OFDM based physical layer. So we have OFDM. We already know we have different multiplexing techniques in our digital communication, like TDM, FDM, OFDM, WDM, OWDM, like that. So here the physical layer is based on the orthogonal frequency division multiplexing. So the WiMAX is physical layer is based on orthogonal frequency division multiplexing, a scheme that offers good resistance to multipath and allows WiMAX to operate in non-line of sight conditions. This is one more silent feature of WiMAX. It is based on physical layer is based on orthogonal frequency division multiplexing. Next, very high peak data rates. So the communication is sometimes it depends on data rates also. So WiMAX is capable of supporting very high peak data rates. In fact, the peak physical data rate can be has 74 Mbps when operating using 20 MHz wide spectrum. When we use 24 GHz wide spectrum, so the speed is predefinedly it's applicable for 74 Mbps megabits per second. The next one, scalable bandwidth and data rate support. Scalable bandwidth, it moves on increasing. WiMAX has a scalable physical layer architecture that allows for the data rates to scale easily with available channel bandwidth. So the transmission of the signals, it depends on bandwidth. For AM, for FM, or whatever the modulated signals are available there, so that is the based on the bandwidth. So here one of the future of WiMAX is scalable bandwidth and data rate support. So next, move on to the remaining silent features of WiMAX is adaptive modulation and coding. Adaptive modulation and coding, it is one of the adaptive modulation is nothing but one of the digital modulation technique like PCM, DPCM, DM, ADM, like that. Pulse code modulation, differential pulse code modulation, delta modulation, adaptive delta modulation. These are the digital modulation techniques. So here WiMAX support a number of modulation and forward error correction code schemes that allow schemes to be charged for user and per frame basis based on the channel conditions. It allows WiMAX is supported for adaptive modulation and coding techniques. Next one, link layer retransmissions. So WiMAX supports automatic retransmission request at the link layer for connections that require enhanced reliability. So to improve the reliability, we use link layer retransmissions also in sometimes. So ARQ enabled connections require each transmitted packet to be acknowledged by the receiver. Next, it's supported for TDD and FTD. TDD and FDD, time duplex, time division, duplex, frequency division, duplex. So these two are is nothing but multiplexing techniques. More number of signals can pass through single channel only. So more number of signals, it is multiplexing concept. So based on time division multiplexing, the time slot is divided into some number of channels. So here time is divided. For example, 120 milliseconds time is available. So we have 4 channels. So by 4, that is for each channel we divided into 30 milliseconds. So that is the time slot is divided. Here frequency division. The frequency of the entire signal can be divided as per the time slots. So here IEEE 802.16 802.16a, that is 2.5 support both division multiplexing and frequency time division multiplexing and frequency division multiplexing, as well as it is a half duplex FDD which allows for a low cost system of implementation. So this is the one more feature of WiMAX, that is support for time division duplex and frequency division duplex. So overallly it support for multiplexing techniques. Either it is time division, either it is frequency division, whatever it may be. The overall information from this point is WiMAX is supported for multiplexing concept. So within that multiplexing, we have different types of methods. TDM, FDM, WDM, OFDM, like that. Okay, so next remaining features of WiMAX is WiMAX uses OFDM also. We already know orthogonal frequency division multiplexing. OFDM stands for as a multiple access technique. It is one of the multiple access technique whereby different users can be allotted different subsets of OFDM tones. So multiplexing techniques different, multiple access is total different. Next, flexible and dynamic per user resource allocation. Both uplink and downlink resources allocation are controlled by a scheduler in the base station. Uplink and downlink frequency. Uplink frequency, this is downlink frequency, transmitted to a certain point, that point to receiver. Capacity shared among the multiple users on a demand basis using a brushed TDM scheme, time division scheme. So the last one, support for advanced antenna techniques. It having the multiple antenna techniques, it having beam forming, space-time coding, and spatial multiplexing. So beam form is nothing but from antenna, the transmitted signal forming like a beam. So the WiMAX is supported for this beam forming also, space timing code as well as spatial multiplexing also. So this is support for advanced antenna techniques. So in that techniques we have beam forming, space-time coding, and spatial multiplexing. Next, remaining features of WiMAX is quality of service support. We already know, we discussed in the first slide only. So the WiMAX is MAC layer has a connection oriented architecture that is designed to support a variety of applications like including voice and multimedia services also. WiMAX systems offer support for constant bitrate, variable bitrate, real-time, non-time traffic flows in addition to best effort to data traffic also. WiMAX system support for this type of some applications like bitrate, variable bitrate, real-time and non-real-time traffic flows like that. Also, MAC is designed to support a large number of users with multiple connections per terminal, each with its own quality of service requirement. The last one, robust security. It supports strong encryption using advanced encryption standard and has a support to privacy and key management protocol. So these are the some important silent features of WiMAX. End with robust security, quality of service support, robust security. Next, move on to the what are the building blocks of WiMAX. So here we have two major building blocks of WiMAX. We have one is the WiMAX base station, second one is the receiver. So from the base station only we have to transmit some signals. So it is nothing but transmitter also. It is also called as transmitter. Next one channel, then receiver. So here, what is the function of WiMAX base station? So here the base station consists of indoor electronics and WiMAX a tower similar in concept to a cell phone tower. It's nothing but a transmitter. Next, WiMAX base stations would use a MAC layer defined in the standard, a common interface that makes network interoperable, would allocate uplink and downlink bandwidth to subscribers according to their needs. This is the function of base station. Next, coming to receiver, a receiver may have a separate antenna or could be a standalone a box or PCM CIA card sitting in your laptop or computer to any other devices. So here, what is PCM CIA? It is one of the Wi-Fi card or one of the module that can fit to the laptop. So personal computer Personal Computer Memory Card International Association. PCM-CIS stands for Personal Computer Memory Card International Association. That it is one look like one module like Zigbee Raspberry Pi module. So that module can attach to the laptop or CPU or any other to connect to the wireless, either a Wi-Fi or any other communication technology. So this is PCM-CIE. So these are the building blocks of Wi-Fi. One is the base station, remaining receiver. Next, we have some reference network model of WiMAX here. 802.16e 2005 standard provides air interface for WiMAX, WiMAX, but does not define the full end-to-end WiMAX network. It can only provide for air interface for WiMAX only. Next, WiMAX NWG has developed a network reference model to serve as an architecture framework for WiMAX deployment and to ensure interoperability among various WiMAX equipments and operators. So below is illustrated IP based WiMAX networks architecture also. I will show you the diagram here. So here reference model diagram of WiMAX here. It is mobile station to base station to access network, then ASNG network, then IP address. The same process will move on backside. This is AAA connectivity service network CSN, then internet, then move on to the ASP network. So it is IP based WiMAX network architecture. So here we have different blocks starting from mobile station to ASP. So what is mobile station first? So mobile station used by the end user to access the network first. In any network, the main function of mobile station to access the network wherever it is. So next, access service network ASN, which comprises one or more base stations and one or more ASN gateways that from the radio access network to the edge point. Next, connectivity service network CSN, which provides IP connectivity and all the IP core network functions. So these are the first three blocks of WiMAX network architecture. Based MS mobile station, ASN access service network, then connectivity service network. So we'll see in remaining blocks. Base station, the base is responsible for providing air interface to the mobile station. So first we have mobile station, then mobile station, then base station. Additional functions that may be part of the base station are micro mobility management functions such as handoff triggering and tunnel establishment and radio resource management. So here one word is handoff mechanism. So the handoff mechanism, that is handoff triggering or handoff mechanism. So for example, so this is one of the area 1, this is area 2. So in this area we have one base station 1. So here base station 2. So there is a car moving from this area 1 and area 2. So this is the example for handoff triggering. So the car is moving from this area. So the car is, when the car is crossing the border from area 1, automatically will lose signal from this antenna. When it is handoff is applied to this base station, automatically it collects signal from the base station 2. So there is no signal abstraction in between these two areas. So this is the concept of handoff triggering or handoff mechanism. Handoff mechanism basically is soft handoff and hard handoff. Soft handoff is nothing but before make the connection before breaking. hard hand of complete opposite for soft hand of mechanism. So this is the hand of triggering. It is supported for by WiMAX. Next, access service network gateway. The ASN gateway typically acts as layer 2 traffic aggregation point within the access network gateway. The additional functions may be part of ASN gateway include infra ASN location management and paging, radio resource management. The last one, connectivity service network. It provides connectivity to the network, ASP, other public networks and corporate networks. So these are the three blocks of architecture: base station, access service network gateway, and connectivity service network. Connectivity service network. Next, IEEE in the continuation of IEEE standards. The WiMAX umbrella currently includes 802.16 that is developed in 2004 and 16E in 0.16 2004 utilizes OFDM to serve multiple services. We already discussed these points. Next, these are some comparison of IEEE 802.16 WiMAX standards. So here the first one is 802.16 802.16A, 802.16E. So in terms of parameters, in terms of spectrum, in terms of configuration, in terms of bitrate, in terms of modulation, in terms of mobility, in terms of channel bandwidth, in terms of typical cell radius and completed. So let's see the first comparison of parameter spectrum. In terms of spectrum, in 802.16 that is 10 to 66, the spectrum range. We have to know the spectrum range for 802.16, that is 10 to 66 gigahertz. Next, for 802.16A it is 2 to 11 gigahertz only. For 802.16E is less than 6 gigahertz. Next, in terms of configuration, it is line of sight, non-line of sight and non-line of sight. We already know what is the process of line of sight communication. Next, bitrate. Bitrate for 802.16, 30 to 134 Mbps. Next, for 802.16A, less than or equal to 70 or 100 Mbps. Next, for 802.16E, up to 15 Mbps. Next, in terms of modulation, which type of modulation techniques it can allow? 802.16 QPSK, 16 quadrature amplitude modulation, 64 quadrature amplitude modulation. So it is one of the QPSK, quadrature phase shift keying. It is one of the real-time communication systems are based on QPSK only. So it is very important technology, communication technology, QPSK, quadrature phase shift keying, that is supported by 802.16. For 802.16A, 256 subcarrier, orthogonal frequency division multiplexing, QPSK also 16 QAM, 64 and 256 QAM also. Next, to 802.16E, same as 802.16A, same 256 subcarrier OFDM using QPSK, same as 16A. Next, in terms of mobility, it is fixed mobility, it follows fixed, it is less than or equal to 75 mph. Next, in terms of channel bandwidth, 20, 25, 28 megahertz for 802.16. But for 802.16A, it is selectable 1.25 to 20 megahertz. Next, 5 megahertz for it is predefined width for channel bandwidth for 802.16E. 5 megahertz that is planned. Next, typical cell radius 1 to 3 miles, 3 to 5 miles and 1 to 3 miles for 802.16E. Next, completed December 2001. It is completed by December 2001. It is completed by January 2003. Second half of 2005. So these are the some technical comparisons of IEEE 802.16 Wi-Fi standard. 802.16, 16A and 16E. Next, move on to the some security functions of WiMAX here. So it is support for privacy also. So user data is encrypted using cryptographic scheme of provided robustness to the provider privacy. Both AES, Advanced Encryption Standard, and Triple Data Encryption Standard are supported. So these are the two advanced encryption methods, that is AES and 3DES. These two are supported by WiMAX, Advanced Encryption Standard and Triple Data Encryption Standard. So it can also 128-bit or 256-bit key used for deriving the generated using the authentication phase is periodically refreshed for additional protection. Next, the user authentication. Authentication framework is based on the Internet Engineering Task Force (EAP), which supports a variety of credentials such as username, password, digital certificates, and smart cards. So these are the some security functions of WiMAX. It support for privacy in terms of advanced encryption standard and triple data encryption standard. One more is device or user authentication. It supports for variety of credentials like user or password details and digital certificates along with some smart cards also. Next, flexible key management protocol. It is one of the security functions of WiMAX also. Flexible key management protocol, protection of control messages, support for fast handover. What is the application? Flexible key management protocol is nothing but privacy key management protocol version 2. It is used for securely transferring keying material from base station to the mobile station, periodically reauthorizing and refreshing the keys. So it's securely for transferring keying material from base station to the mobile station. Next, protection of control messages. In terms of protection of control messages, the integrity of over the air control messages is protected by using message digest schemes like AES and CMAE AC or MD5 based HMAC technique. These are the some message digest schemes. Next, support for fast handover. To support fast handover, WiMAX allows MS to use pre-authentication with a particular target base station to facilitate accelerator re-entry scheme. So these are the three security functions of WiMAX: flexible key management protocol, protection of control messages, along with the support for fast handover. So next, move on. These are the references for this session. WiMAX architecture. References. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.